Hi, and welcome to our first video dealing with algebra and these kind of age problems where we're told something about a person's age or a bunch of people and how their ages are related, and then we have to find either their current age or their future age or how many years older someone is than someone else, and there's all these things we can do, and they're actually kind of fun once you get the hang of them. And here we're going to start with I think something that's maybe a beginning level, right? Something that we can build from. Here it says well, let's read the problem. Here it says that 10 years from now, Orlando will be 3 times older than he is today. What is his current age? So, I mean, the hint here to get started is that we're trying to find his current age, how old he is right now. So that means to me that our variable should be what we're trying to find. So I say x equals the current age. And you don't need to set it up this way, but I think it helps, right? It helps set it up this way. Because now we know that 10 years from now, right, 10 years from whatever age he is today, his age will be 3 times older than he is right now. So now I can translate that to an equation, right? His current age plus 10, because we're going 10 years from now, that's going to equal 3 times his current age. So this equation can be solved, and we can find x, his current age. To solve, I would just subtract x from both sides. And then what happens? Well, x minus x is 0, 10 is still there, and 3x minus x is 2x. Now 2 times something is 10, and that's 5, but we can divide by 2 on both sides to solve. Here, x will equal 5. What does this mean? Well, this means that Orlando's current age is 5 years old, right? Because if we take 5 and we add 10 to it, right, because we're adding 10, what do we get? Well, we get 15. And we're saying in this problem, is 15 3 times older than his current age, which is 5, right? That's x. The answer is yes, because 5 times 3 is 15. So this problem works, and x equals 5. Now, I suggest, that you make up problems like this, right? Say some amount of years from now, someone will be some amount of times older than they are today. What's their current age? So we can actually solve this, right, just by making up something here and trying it out. Let's say in, I don't know, 20 years, Kayleen, right, you can make up anyone here, Kayleen will be 4 times older than she is today. And then you could say, what is her current age? And I want you to try this problem out. You can try it on your own and then watch the rest. But here, we're going to come up with something that's a little bit different, but we're going to use the same technique. So I'll show you that. What is her current age? So what do? Well, again, we're trying to find her current age. So x will equal her current age. And the equation we'll set this time is very similar, right? Her current age plus, well, we're looking at her age in 20 years, so we add 20. We're saying this, if you add it together, it will be 4 times older than she is today. So this will equal 4 times her current age. And to figure out what's happening, we can solve for x. Subtract x from both sides, right? And then we get, well, this cancels out. 20 is still there. 4x minus x is 3x. Now 3 times something is 20. Divide both sides by 3. And here 20 divided by 3 is x. So what's that? Well, 3 times 6 is 18, right? So I know that 3 goes into 26 times, and that equals 18. And there's 2 left over, or 2/3. So here, her current age is 6 2/3. And we can test out, and we should test out that this actually works. So if we take her current age, 6 2/3, and we add 20, right, that equals 26 2/3. The question is, and this was a little bit more difficult to see, is this age 4 times her current age? To test that out, we can do 6 2/3. I think an easy way to test this out is to multiply that by 4. So when we do that, we multiply 6 2/3 by 4. 6 times 4 is 24. 4 times 2/3 is 8/3, right? Because 4 times 2 is 8, and Really, we're counting the number of thirds here. But we're not done yet, right? Because 24 and 8 thirds equals 24 and plus 2 and 2 thirds. Because 3 goes into 8 twice, it's 2 whole numbers, and there's 2 thirds left over. Add these up and we get 26 and 2 thirds. So yes, it works, right? We took her current age, multiplied it by 4, and got an age, right, that is 4 times greater. So, and that matches what we have here, I'm sorry. Right, if we add 20 to our current age, that age is 4 times her original. They might ask you, if you get a fraction like this, how many months is that? Well, there are 12 months in a year. So if you get a fraction like 2 thirds, multiply it by 2 thirds. Oops, multiply it by 2 thirds. To do that, of course, it's 2 times 12, or 24, over 3. This means 24 divided by 3, or 8. What does that mean? That means that her age currently is not really, well, it is 6 and 2 thirds, but that's in years, right? So you could say it's 6 years and then 8 months. And that's the same thing as 6 and 2 thirds years, but they might ask for it in terms of years and months. Now, what's fun is when you're creating some problems, you might get some answers that are technically impossible, right? What if we change this from 4 times to 1/4? What will happen? So let's clear this off a little bit. So when you're creating problems like this, you want to think about what is actually possible and what's not. And don't worry if you're not able to do that from the beginning, because that will come with experience. So what are we going to do? Well, instead of 4 times older, we're saying 1/4. Why is that weird? Well, in one sense, right, how could you become, as you age, your number gets larger, you get older. So how is it possible that your age in 20 years will be 1/4 of the age, right, the age that she is today? So you're creating something that's not really possible, right? Because when you age, obviously you get older. That she is today. But it is fun to actually solve this and see what's happening here, because we can still get a number. We just need to think if it actually makes sense. So her current age again is x, and we're adding 20, right? But we're saying that when you do that, you get 1/4, right, of her current age. What will happen here? And you might be able to predict already what's going to happen, but let's try it out. Subtract x from both sides. This is 0, and 20 equals, well, what's a fourth minus 1, right? Well, that's, think of it, if you have a quarter and you take away a full dollar, you'll have a negative amount. And in fact, what you'll have is negative 3/4. And you can calculate this by setting it up. You can do 1/4 x minus 4/4 x. That's a 1x. And then 1 minus 4 is negative 3. It's fourths x. You can work this out. But here, to solve for x now, we have to multiply. Well, one thing we can do is multiply both sides by negative 4/3. And again, that's just a pretty common technique in algebra. If you're given a fraction, to get rid of it, or to balance it out to 1, you multiply by the reciprocal. Like if I had 1 over 2, and I want to make that equal 1, I would multiply by the reciprocal, 2 over 1. And that, of course, equals 2 over 2, which is 1. So in other words, any fraction you're given, flip it and multiply to make it equal 1. Same things here. Negative 3/4 times negative 4/3 is just 1. Here, 20 times negative 4/3, well, 20 times negative 4 is negative 80. Negative 80 over 3 is x. What does that equal? Well, know that 3 goes into 80 26 times fully, right? Negative 26 times, because that's equal to negative 78. And then there's 2 left over, so it's really negative 26 2/3. So look at this. We've gotten an age that's negative, and that's not really possible, right? You can't have a negative age. It's not how we count our ages. But with numbers, of course, this does make sense. Why? Well, if you have your current age as negative 26 2/3, in 20 years, right, if you add 20, what will that be? Well, that would be negative 6 2/3. And if you compare these two ages, negative 6 and 2/3, right, is 1/4 of negative 26 and 2/3. So it's gone up in value, but the number itself, the absolute value, right, is smaller. It's closer to 0. So these kind of problems can create interesting results, especially when you make them impossible. Anyway, I hope this helped. In the next video, we'll look at some tougher and different examples. Thanks a lot.